Hey guys, in this video we are going to discuss this infinite series. So this one, if you look at this sine starting from here, look at the variation of n goes from 1 to infinity. So n starting from 1 2 3 4 5 6. So you know that this function, so I plotted sine of 1 over x from 1 to 10. You can see that this function is positive, and if you find the limit of sine of 1 over x as x tends to infinity, so the limit of sine of 1 over n, right? So here this function is continuous, sine function is continuous, so then you can so this one is same with sine of limit n goes to infinity 1 over n. Yeah, this one is same with sine of 0, which is 0. So can see that the limit of this function is equal to 0 as n tends to infinity, right? So if you plot sine of 1 over x, so it decreases to 0. So you can show that. So you can show that by differentiating sine function. So f of x is equal to sine of 1 over x, right? So the derivative of f is equal to cos of 1 over x and negative 1 over x squared. So in this range, right, in this range, this one is a positive function. And what about this one? If you look at the cos function, so if you plot cos of 1 over x from 1 to 10, so it comes out to be like this. So that one also a positive function. So this term, this one also positive, this one also positive, and here you have a negative. Then the derivative of f is negative over this interval, right? So therefore this one is decreasing, f is decreasing. We know that the limit of f as limit is 0 as x tends to infinity, right? Therefore sine of 1 over x, 1 over n is a decreasing sequence. This sequence is decreasing to 0, right? So this is a positive, this is a non-negative series. So all terms of this series is non-negative, right? Then you can apply limit comparison test, I think. So look at limit comparison test. If you have two series like this, both are positive series, important, right? If this limit a sub n divided by a sub b sub n, the limit of this one is a finite value, positive finite value, right? Then you can say both series converge or both diverge, right? So here we know that this infinite series 1 over n is divergent, right? And what is the limit of this? Sine of 1 over n divided by 1 over n. So limit of this function, this term, this sequence goes to 1 as n goes to infinity, right? So this is a finite positive value. Therefore, because this one is divergent from the limit comparison test, so you can say that this infinite series is divergent from the limit comparison test, right? Now if you look at this infinite series, this time you have sine of 1 over n squared, right? And we know that this is non-negative, all terms for all n, this is non-negative, right? So also the limit of this one is goes to 0. Here look at this. So because sine function is continuous, there you can take this limit inside of sine, because this function is continuous, right? Then sine of 0 is 0, then limit of this function is 0. And also you can show that this function is decreasing by differentiating, by finding derivative of this one, right? So if you differentiate this, you get this one here, right? So this is positive in this range, and this one also this one also positive, right? This one also positive. Then f prime is negative in this range, therefore this one is f is decreasing, and we know the limit of sine of 1 over n squared, the limit is equal to 0 as n tends to infinity. Therefore we know this is non-negative for all n, this is non-negative, right? Therefore, so we can use limit comparison test to evaluate the convergence of this series, right? So we compare this series with this. We know that 1 over n squared is convergent, and we can find the limit, and we know the limit of this one is equal to 1 as n tends to infinity. So this is finite, therefore since this is convergent, therefore this series, I was using the limit comparison test. By using the limit comparison test, we showed that this one also convergent, right? So because this is convergent. I hope you understood checking whether a series convergent or divergent. So make sure that you have to. So make sure this is non-negative non-negative terms. Here this one is negative, otherwise you cannot use limit comparison test, right? First show that this one is non-negative, and show that the limit of, if you want to compare with this, then show that limit of this one is finite as n tends to infinity, right?